Good morning, Year 11. It's morning when I'm making this video now, although it may not be morning while you're watching it. Okay, this video relates to exercise 14E of our text. The exercise is called Symmetry Properties of Circular Functions. Okay, so you can see what I've got here is I've got a unit circle that's drawn, and the diagram you can see is actually very busy at the moment. But what I'm going to do over the next few minutes is go through what's on here. It's very important for you to know and to understand. I've got to try and sit still because my camera keeps coming in and out of focus. Okay, but this diagram is copied from page 491, that's page 491 of your text. So you can always refer to that one as well while you're looking at this video. Okay. So what have we got here? We've got a unit circle, okay, and it's got a cross through the middle of it because what it's got drawn on it is it's got four angles drawn on it. Okay, and the reason there's four angles drawn on there is that for every angle in the first quadrant of the unit circle, there is an equivalent angle in every other quadrant of the unit circle. So what I mean by that is that we've got theta here, okay, in the first quadrant. So that's the angle from the x-axis there going in the anti-clockwise direction. That's theta. So that's the angle there. Now the coordinates of this point P represent cos theta, sin theta. Okay, this length here represents sin theta. This length here represents cos theta. Okay, and we've worked with the first quadrant, and we know it very well. Okay, so this point here is the point 0b in terms of coordinates. So again, that's the value for sin theta. That's the value for cos theta. Okay, now if we go around here, the equivalent angle in the second quadrant, quadrant 2 up here, is actually pi minus theta. Okay, pi is here, so let's write pi in here. That's the angle pi. 180 degrees is the angle pi in radian. Okay, and so the equivalent angle here is pi minus theta. Okay, so theta could have any value here in the positive in quadrant 1, and the equivalent angle is pi minus theta because you go all the way around and then you come back the same angle, and it's equivalent. Now, what that means here is that we can work out the sine, the cos, and the tan of this equivalent angle, and we can see what the relationship is between the sine, cos, and tan of the angle in quadrant 2 and the sine, cos, and tan of the angle in quadrant 1. So over here, at this point on the unit circle, the sine of this angle, okay, which is pi minus theta, so it's the angle all the way around here. If we go all the way around here, that's pi minus theta. We can see that the sine of this angle is the same as the sine of this angle. Okay, it's exactly the same value. That distance there, it's in the positive direction. It's the same distance. We can see that the cos of this angle has the same magnitude as the cos of the angle in the first quadrant, but it's in the negative direction. So cos of pi minus theta equals negative cos theta. Okay, and we know that the tan of this angle, okay, is the negative of the tan of this angle, because to get the tan of this angle, we go up here. I didn't draw it in, but imagine we've got a tangent going up here and we've got the angle going up there. That's the tangent of the angle up here. Okay, if we're in this quadrant, the tangent is equivalent, but it's down here. Okay, so in quadrant number 2, tan is negative, and I've already said sine is positive, cos is negative, tan is negative. Okay, so this is the equivalent relationship to quadrant 1. If we go around to quadrant 3, okay, the equivalent angle in quadrant 3 is pi plus theta. Okay, pi plus theta. So if we look at this particular angle, the value for sine of this angle is the negative of the value for sine in the first quadrant. Okay, so sine of pi plus theta, that's what that says there. Sine of pi plus theta equals negative sine pi. Negative sine theta, sorry, I'll read that again. Sine of pi plus theta equals negative sine theta. So that value is the negative of that value. Cos of pi plus theta is the negative of cos theta, because this value here is the negative of this value here. Tan theta is the same as in the first quadrant, because we always go to the right, we always go to the positive, the tangent drawn on the right side of the unit circle. Tan is this value here, from there to there in quadrant 3. Okay, so in quadrant 3, sine of the equivalent angle, sine of the equivalent first quadrant angle is negative sine theta, the cosine of the equivalent is negative cos theta, and the tangent is the same value. Okay, last one, we go around to the fourth quadrant. The equivalent angle in the fourth quadrant is 2 pi, so we can write in here 2 pi, 360 degrees is 2 pi. 2 pi minus theta gives us the equivalent angle in the fourth quadrant. So if we look again, sine is negative. It's the same magnitude, but it's negative of what's in the first quadrant. Cosine, cos, is exactly the same because it relates to exactly the same coordinate there. And tangent, tan, is negative. I moved it. Tangent is negative because we're going down here and the tangent is down here. Okay, so in the fourth quadrant, sine is negative, cosine is positive, tan is negative. Okay, so you might want to run through this again. You might want to take a look at the diagram in your textbook on page 491 and just get a bit of a sense of it. There's a rule that goes along with this. There's something that helps us out. Okay, and it's called the Astc Rule because we've got all S, T, C. Okay, and what this means is that in the first quadrant, sine, cos, and tan are all positive. Okay. In the second quadrant, sine is positive. In the third quadrant, tan is positive. And in the fourth quadrant, I wrote fourth without a U there. In the fourth quadrant, cos is positive. Okay. So these letters represent what is positive, A, S, T, C, in each quadrant. Okay. And you can remember that with a simple phrase, all stations to city. Okay, all stations to city. Think about a train. Okay, not that we have trains in Doncaster still. All stations to city. Okay, ASTC. So this is how you can remember and relate things back to the first quadrant. Okay, so the exercise has got questions like this in there. Okay, so if you've got a value for sine, it's okay, if sine of x equals 0.3, then what's the value of sine pi minus x as an example? Okay, so if theta is if that's x, okay, sine of pi minus x, or pi minus theta, it equals sine theta. So we say, well, that's in the first quadrant, that equals sine theta. So that equals 0.3. Okay. What about pi plus x? If sine, oh, actually that should be x. I wrote theta because I got theta on the brain. Okay. If sine of x equals 0.3, what's the value of the sine of pi plus x? Okay. Pi plus x is down in this quadrant. ASTC, it's going to be negative sign. So it equals negative sine x equals negative 0.3. Okay. The sine of 2 pi minus x. 2 pi minus x, that's 2 pi minus x. Okay, that's in this quadrant. that also equals negative sine theta, sine x, sorry, negative sine x, which equals negative 0.3. And the last one here, what's the sine of negative x? Okay, negative x or negative theta. Didn't explain this one before, but I have mentioned it in the past. Negative x or negative theta is the angle you get when you go in the other direction, okay, when you go this way. Okay, so if that's theta or x, that angle there represents negative theta. Okay, so the sine of negative theta is negative sine theta. Okay, so it's the same. The answer to D is the same as C. It's the same angle, in fact. Negative sine x, which equals negative 0.3. Okay, so that tells you what you should need to know to get on with exercise 14E. Again, if you have any questions, ask your teacher. If you need to, watch the video again. I'll see you for the next one.